Okay, we're about to begin a new unit. As we begin a new unit on static electricity, chemical reactions, our current model of matter will not be able to be used to explain those things. So we have to develop our model of particles even further. Okay, we're going to be talking today about the atomic structure. So what you're seeing here is when we did our PhET simulation with states of matter, you saw neon as being one little particle, which is kind of what you thought solids look like magnified millions of times. Little particles really tightly close together, vibrating back and forth, held by strong attractive forces. Now with water, water's particles did not look like just a circle. They actually look like three circles. Okay, two white little circles attached to a red circle. You might have heard H2O to refer to water. Water is actually made up of three smaller particles called atoms. So today we're going to talk a little bit about atoms. Okay, so if you go back in history, many years ago, 460 BC, Democritus developed the idea of atoms. He actually thought that if you took like a sugar cube and you pounded it up with a mortar and pestle, you'd reach a smaller little piece of sugar. Okay, and the smallest possible piece of sugar that you could get, he thought that would be called a sugar atom. Reduce it smaller and smaller. Now, he called those smaller pieces atoma, Greek for indivisible. That means it cannot be cut, no cut. So an atom is the smallest possible piece of matter that still has its properties that cannot be divided any further. There's no such thing as a sugar atom. We'll talk about that in a little while. John Dalton in 1803 believed that he suggested that all matter was made up of tiny spheres, which we call particles today, right, in our classes, that were able to bounce around with perfectly elasticity and called them atoms. Okay, so John Dalton did name them atoms. So our current model goes back to 1803. So we need to develop our model to 2021 to be able to explain some of the things that we're going to see here in the upcoming units. So an atom is the building blocks of all matter, the smallest piece of anything. Atomos means indivisible, cannot be divided, cannot be cut. So the smallest possible piece of anything is an atom. And there's no such thing as a sugar atom, so we're going to have to go further in terms of what sugar is made up of. Water is made up of hydrogen and oxygen. We'll get into that in a few minutes. A molecule, it could also be called a particle. A particle is a general term, but it's a group of atoms, like we talk about a water molecule instead of a water atom. So here's a sugar particle. Sugar particle is kind of complex. You see a sugar particle is actually made up of carbon, oxygen, and hydrogen atoms. So these are all the atoms that are made up of one little particle of sugar. Okay, now the lightest atom, hydrogen, weighs about, and I should has a mass of 1.7 times 10 to the negative 24 grams. Okay, that's a small mass for one atom of hydrogen. Now, when you look at water molecules kind of as a liquid, they're close together, they're vibrating back and forth, but they're actually spread far enough apart where they can slide over one another. If you magnify that more to see what kind of particles make up water, you would see that it's made up of three particles, two hydrogens and one oxygens. But in every drop of water, there's 1.67 sextillion molecules. So a molecule is small, atoms are even smaller. Okay, so when you magnify this water particle, what you would see is two blues and one yellow. If we magnify the blue one a little more, you would see something that's made up of smaller particles. And then the oxygen atom. So water is H2O. Okay, that's one molecule. So when you zoom in on the oxygen is actually made up of different particles also. Every atom is made up of protons, neutrons, and electrons. That's what makes an oxygen different than a hydrogen. So within an oxygen atom, there's a small, dense center, which has protons and neutrons in it. The hydrogen is the simplest atom. It's only made up of one proton and one electron. You can see how atoms of different elements are different. And there's only a certain number of elements that are out there. You can find these elements on the periodic table of elements. And there's, about 92 naturally occurring elements, around 120 or so elements make up everything around us. So the basic structure of an atom, of these 120 things that make up everything around us, is a very, very, very tiny nucleus. Inside the nucleus is a small, dense center. It's made up of most of the mass, almost 99.9% of the mass. Inside this nucleus, you'd find protons or positively charged particles and neutrons. They're held together by strong nuclear forces that cannot be taken apart. When we get into static electricity and chemical reactions, we're going to be talking about these little things that are circling the nucleus of the atom, which are called electrons. Okay. Now, in this, the electrons, there are moving around in the cloud on the outside of an atom. Okay. The electron cloud makes up about 99% of the volume. So most of an atom is actually empty space. Doesn't have anything really there. So throughout history, the atom has changed over and over based on new evidence. As we collect new evidence, just like in science class, our models have to change. So the model that we have right now is in 1803. We would like you to get to, maybe a 1913 model or so, 1930s, to be able to explain some of the things that we're going to get to with static electricity and chemical reactions.